let's get started. So, hey guys, today we'll be focusing on this problem called forward a port using the multi-purpose relay tool, right? And yeah, let's get started on this one. So this is a very fun, challenging problem, right? Because if you have spent some enough time in system design, then you would realize that how fun it is actually to solve this instead of drawing these boxes. Right? I mean, this box is very useful for this, but I'm talking about the general preparation. So most people will just make these boxes and feel confident that they know system design, but eventually real engineers are the ones who are born obviously from the Eximus lab as well, and the one who learns on the ground itself. So Eximus lab, just to give you a bit of intro, that it gives you a lot of playgrounds where you will be able to solve real world challenges, right? And they are pretty fun because these are very basic thing, like talking about if you want to deploy a website and you want to play around with networking Linux concepts, then this is a go-to website for me to actually learn things, right? I mean, you can set up things, but setting up things, as you know, might consume a lot of your own personal time, and it's not feasible enough, right? So without wasting much time, let's get started. So the question says that there is an HTTP service which is listening on this given port, right? 127 dot. This is the local address of 5000 port. Our task is that we need to make this service available on this given address, and there are certain criterias. The criteria is that we are not allowed to change this service configuration or restart it. So the thing is that we should use the Socat, which is a multi-purpose relay tool, to map the given port, right? So as you might see over here is that we have a client which is sending a data on this local address. There's a proxy which is listening on this given address. And once the data has arrived, it connects to a given server based on the mapping which we have already configured as part of setting up the proxy. It goes any data which a client sends on this given address, it goes and forwarded to the server, right? Which is listening, right? On with it connects to this given address, and the server actually listens to this given address, right? So that is a given criteria, right? That is a given criteria which has been provided over here. Now, the thing is that the I wanted to explain you some basic thing, right? So imagine that you're a corporate employee, or if you're a corporate employee, you could actually relate to me pretty well. So in a corporate building, what eventually happens is that you might have wondered that whenever you want to connect to the internet, you're always disallowed. Like in the sense that you're disallowed certain websites. That's what I meant. You cannot visit all the website which is present, and this is some policy as per the corporate itself, right? You cannot just go around and play some gaming websites, or like I know if you even if you can, you can't just go around and visit some phishing website. So corporate is actually trying to protect you, right? And the way it do is that it actually set up a forward proxy for you. Now what eventually happen is that in the forward proxy, your browser will be already configured. Let's say that this is your laptop, right? Your laptop will have some browser, right? And this browser will be automatically configured with some reverse proxy, right? So let's say that the address of the reverse proxy is some local address, like I'll just use corporate dot local, right? And on some given port, let's say 5000, right? So all of this can is configured. Maybe maybe it's done manually or as part of the some automation process, which I'm not aware of, right? So that's one given thing. And your laptop wants to connect to the internet. So whenever your browser makes a request, the browser understands that okay, there is a proxy setup. I will go and make a request to this one, right? So all your request actually does not directly go to the internet, like to the router, which if eventually connects to the internet, it hits this proxy first. And when it goes to this proxy will handle the further logic of further like it might handle the further logic that okay, for this given website I will allow it, basically whitelisting and blacklisting the website, and on behalf of you it will make the internet connection, like it will assess that given URL which you have typed, and then it will return that URL back to you, right? So that's one given thing. So eventually when you think about it, this is your client, this is your proxy, and this is your server, right? This is some remote server which you were trying to access. Maybe somewhere google.com, something. This is Google server, right? So when you connect, your browser sends a request to this given proxy, right? The browser sends a request to this given proxy, and eventually it reaches outside. So this is a path of a forward proxy, right? We are going to discuss something more. We are going to discuss something as part of the. I mean, if there is something forward, there will be also backward. But unfortunately, we don't have a backward proxy. We call it reverse proxy, and I don't understand why. So we have something called reverse proxy, right? And what does reverse proxy do is that, let's say that there is some app, let's say this one, right? And let's say that you have some virtual private cloud, right? And you have certain apps, right? And the thing is that you want to expose these apps out to the outside world. So what you eventually do is that you generate certain link like HTTP s dot app dot example dot com. Then you have another one like app. Yeah, yeah, typing it correctly, right? Yeah. App 2 dot example dot com, right? So basically what might happen as part of this is that anyone who wants to access this given URL will first type this URL obviously, and then it will reach your given server, right? But it's just not as straightforward, right? Your server might have some name to it, right? So there might be mapping, right? And eventually when it reaches your server, there might be a lot of confusion, right? Because there are eventually two app which is running, right? Even when you type the this thing correctly, right? Let's say that this is 172.10.1.6. So this is your IP address of the given server where you are running your applications, right? So I'm just given a some random IP address. Don't worry about it. But there might be certain problem, right? There might be certain problem because what might eventually happen is that when your server is actually when your client is actually making a request, it does not know that it's the request is meant for this app or it's meant for this app, right? So in those scenarios, you can use a proxy, right? And also, it's a very good idea that even if you try to map that, okay, even if you try to map, you start listening on this particular port and you try to map that to this given application, then this is again a bad approach because you're tying your application to that given address, right? And that would make it very tightly coupled, right? Because tomorrow, if let's say that you want to move away this app or bring another version of the app, so that change would become very tedious, right? So what you can have is that you can have a reverse proxy where you store the mapping. Let's say that this app is running on 127.0.1.5 on this given port. So eventually your reverse proxy will say that, okay, all the request for which is coming from app1.example.com will eventually be handled by this given application, right? So it will just forward it, right? Same thing applies for the second application itself. So all the request which is made to this, it will go and talk to some another one, 0.6.8080, let's say that. So this will eventually be mapped to this given application. Now you look how this mapping is done. This can be usually done with set when you're setting up the nginx. So and it's a very straightforward thing. There is nothing fancy over here, right? So application make a request. Your reverse proxy takes care of how to handle these things. Nothing fancy. So now you try to understand that how beneficial is these things. Scalability becomes very easier for me because now Nginx can also work as a load balancer for me, right? Now your client does not know the inside of your like it does not need to care about what you're doing on your virtual private cloud, right? You can have n number of applications and the reverse proxy will act as a abstraction layer. Okay. So that's one given thing which I wanted to explain you guys, right? So after this, the problem is not much, right? I think so. When I explained you all of this, this problem itself becomes very easy. So the people who want to understand how they can actually approach this, always use man, right? Whenever you're in trouble, just use man and try to understand that whenever you're making an HTTP, whenever you're trying to deal with HTTP service, right? You always try to deal with a TCP connection because HTTP is something which runs on the over TCP, right? So let me quickly search for TCP, and you can see there is a TCP over here, right? And the way the format is that socat TCP listen, and we want to listen at this given port, that is 6000. So we specify this 6000 port. Ideally, there are other useful parameters which I wanted to discuss, but I will discuss two different parameters: fork and reuse address, right? So these two are important part for this given problem, right? So reuse address, let's say that the client has you made a connection to the proxy, everything is good enough, right? This is your client, this is your proxy, you made a connection, and let's say that you didn't use this flag or option reuse address. So let's say that the client disconnected and try to reconnect. So that there will be a jitter over here, right? The proxy, when you try to reconnect, for example, the client wants to reconnect, it might show it might show you that okay, there is this given port, or this given port is busy, right? This given address is busy, so you cannot connect. So it will just directly throw this error for a very small period of time. But when you use this reuse address, this becomes immediate. For example, client disconnects and reconnects, it's just a matter of uh not even it's a blink of eye, let's say that, right? That's one given thing. Now I want to discuss another thing, bind. So obviously current we want to bind this to this given address, local address 0.0.0, right? So that's why we use a bind flag for this one. And finally the poke flag, right? So let's say that currently we have only a single client over here, right? Single client. What if there are multiple clients, right? What if there are multiple clients who wants to send the data, and it does, how does it handle it, right? This is something which I wanted to take it further of as part of this challenge. What if there are multiple clients, right? So as part of the multiple clients, what might eventually happen is you think that you, okay, let's assume that there is some command, right, you typed, and you made a connection from the client to the proxy, and then everything is good enough. Now another client comes up, client one made a use this command, and everything was good. Now let's say that another client two comes up and also uses this command, same command. Do you think it might work? No. Without specifying the flag poke, you might not be able to achieve this thing, because for the client two, what might eventually happen is that when you use this command like the socat TCP listen without fork, what might happen is that the client one, so basically the socket will just throw up an error saying that the address is busy, you cannot use it. But when you use a fork, eventually it generates another TCP connection. It generates another connection for you, right? And that connection is something which it becomes something very scalable, right? Because you can have multiple clients, and all of these clients can eventually use these things. So that's one given thing, right? So right now, if you make a connection, it's just one single TCP connection. But if you use fork for each client, there will be a new connection which is generated. And how does it handle? Because of fork, right? There will be a parent, there will be a child. Child will eventually handle all of this thing, right? So every time you use this thing, this will not run on the main. It will run on the fork. The child, not it will not run on the parent. It will run on the fork itself, or the child process. Sorry, right? So a lot of saying, right? A lot of saying. Let's finally solve this challenge right now. So if I get that correctly, we use a TCP listen on this given port. Then we use a bind with 0.0.0. Then, as I had mentioned, we are going to use reuse address, reuse address with fork, and we are going to specify the address of the proxy itself over here. 0.0. Done. So notice the services listing on the port 5000. Don't go behind these figure, because this is just an rough figure, not an exact representation, right? So let's see. Okay, it failed. Let's see where we did a mistake. I think so. I might have added a bit of space. Let's go ahead and make fix these things. Okay. Okay. It's not TCP listen. It's TCP, no, it's not TCP underscore listen, it's TCP dash listen. So let's fix it. Okay, it's not reuse address. What is it? Did I use the spelling correctly? It should be this thing. Okay, it's not getting. So let me open this thing. What was the this given thing, right? I think so. It was reuse address. I mean, if we do not even use that, dude, it's fine. I mean, why I am spending time? I mean, you guys go figure it out. My part was that I want to make you guys feel comfortable enough to show you that it actually works, right? So that's it about solving this problem. And for your homework, you figure out that why that reuse address is not working. And I would also encourage you guys to further go and understand this man socket, because there are a lot of commands over here, right? This is I mean, you can't have a playground where you can cover every single thing. Some things has to be driven by yourself itself, right? So here you can try to explore what are the different flags, and that's how you differentiate between a engineer who just draw boxes and the engineer who actually plays with right? Be a man or woman. We need to make it gender neutral. But anyways, guys, see you soon. Hope you enjoyed this session.